Thanks, everyone.
With a round of applause, yeah.
Thanks, everyone. So my name's Rob. So I'm one of the co-founders of a company called Macroscope. So I've been working in AI for a while. I had a ML research company that got acquired by Twitter. I was VP of ML for a while there before moving into consumer product, working with some of my co-founders, Kayvon, who is leading consumer product over at Twitter. And since leaving Twitter, we wanted to go and start a company to solve some of the biggest problems that we had. And the biggest problem I had at Twitter was understanding what the hell was going on, right? Twitter was a very big organization, was a lot of stuff happening, right? Like the biggest part of my job was figuring out what were people working on, what were they doing, what was being shipped, were the things that we wanted to be worked on being worked on? Like had we shipped this thing that we discussed a week ago? And the only real way to answer these questions was either having lots of very annoying project managers going and chasing people, or having a ton of meetings that no one wanted to be in. So we thought, okay, there's got to be a better way of doing this. How can we solve this using AI to avoid people having terrible meetings, having to spend all of their time answering questions from their manager about the status of stuff? How can we just do this for you so people can actually spend their time building? And so to try and solve that, we built this company. This company is called Macroscope. And so we do a bunch of things, but fundamentally we help you understand what is being worked on, what are your colleagues working on, like what's shipped. And so I think like for this audience, let's focus on Slack. Like our company, we're like 10 to 20 people. We're mostly working in Slack. This is where we're communicating. And so if you want to go and understand what people are shipping, often you have to like go to GitHub and go read some like terse commit messages. Maybe if you're lucky, people are doing pull requests. Maybe if you're lucky, those pull requests have some kind of sensible description. But often the time, you have to actually go look at the code. And so we kind of solve that problem for you, right? You can go look at Slack right here, and we can see that Claire committed a change that changed something to the front end, like has a visible change, and here's what she did. And if I wanted to go look at it on GitHub, I can go through to it. But without her having to write a commit message, without her having to actually go write a load of stuff in her PR summary, we can just see, as she's committing, what she's doing. And that means that I can then just keep up to date with what's happening just by literally reading Slack without any meetings, without any overhead. And then let's say I wanted to understand what people are working on, right? So let's say I wanted to understand, like, what did I do today? Great question. And Macroscope will go away. It has all of the context of all of my commits, of all of my PRs, and it can come back and tell me, hopefully, what it is that I did today. But more than that, it also has access to all of our code base. So I can ask it questions like, Macroscope, how does our code review work? And it can go away and do that for us as well. And then let's say, like I was working on some stuff on the Waymo over here, didn't get all of that done. Let's say I wanted to go get some of that stuff done now. I can say, okay, Macroscope, can you change the code review thinking instructions to focus on correctness bugs. And Macroscope can go away, go look at our code base, figure out what it is I'm talking about, and it can go open a PR against my code base trying to solve this problem for me, which I can then go pick up. And so this essentially is one of the best interfaces. So apparently today I made 4 commits. I did some tidying up. I fixed some stuff on Rust. I did some other things. I kind of say, okay, like, how much time did I spend on this? And Macroscope will go away and answer these questions for me. And then let's say that I wanted to go and look at a feed of what people worked on today. I can head over to the commit stream, and I can literally see a feed of all of the work that's been done. I can also see when it's been released. So just looking at this, I can see like John had a commit today, committed to the development branch. It's already been released. It's already on main. I can go and see like what are the things that's happening in feature branches. And again, this is all happening without anyone actually having to write commit messages or like do anything. This just all happens in the background. Or I can go look at like, what did we ship today? If the internet's working. But the other big bit that we offer, in addition to all of this, you kind of see here, is we actually provide summaries on the pull requests. So I can go look at a pull request. Actually, here's my tidying up pull request that I did earlier. And you can see, again, we generated the description for you. We already know what the context is. We know like what the purpose of this was. If you're connected to any like linear or JIRA tickets, we can pull all of that information in. We can populate all of that. You'd see ticket links if there's one that was relevant. And we can also help you with reviewing, right? Like, so there's a section here, suggests where to go start. You can click on this, you can go straight to the right bit to go review. It's pretty helpful. And then in addition to that, we've actually gone and done a code review. So you can kind of go look at, see if I can find one that actually has some comments. But we essentially went away and did a bunch of code review. Like, here's a PR that we generated earlier just by asking Macroscope to go do a review, go generate a PR for us. And one of the things that's interesting about our code review is that our code review actually uses native AST crawling. So we're not just like looking at embeddings. We're not just like guessing at what exists in your code base. We're actually using the AST parsing that exists within each of the languages that we support. And we're actually looking at the code graph and pulling in all the relevant context so that when we're reviewing a piece of code, we're not just looking at the code, but we're looking at how it's used. We're looking at what it's calling, like the entire call graph. And so that means that we're able to pick up on bugs that the other coding tools just aren't capable of doing. We've found as a result that we're able to detect far more bugs than a lot of the competitors. So we actually generated a benchmark to look at this. We went and mined GitHub. We found a whole bunch of open source repos. We looked for things like bug fixes. We then went back, found the commit that introduced the bugs that bug fixed, and we said, like, how good is Macroscope at actually detecting that original bug? And these are actual production bugs in open source code. And we ran that for our tool. We also ran that for CodeRabbit, Cursor, greptile, a bunch of the other tools. And we found that we were able to detect substantially more bugs than any of the competition. And particularly, I think one of the things that's interesting is like, okay, sure, recall is one thing, but precision also matters. You can detect all the bugs if you're happy with lots of false positives. But actually, as you'll see in this chart, Macroscope's actually really interesting because we're able to detect more of the bugs from this data set that we generated than any other tool, but also with substantially fewer comments per PR than greptile or CodeRabbit. So that's less time having to go and read automated code review comments, and a higher likelihood that we're detecting bugs that actually matter in production that are going to cause issues. And so that's really just like a high-level tour of a lot of our features. You can sign up online for Macroscope. We have a free trial. If you email us, we'll provide a discount for anyone here. Just mention you're at this event. We're also hiring.
Who should they email?
Oh, yeah.
Support@macroscope.com.
Support@macroscope.com. Excellent. Email support@macroscope.com, say you're here, and we'll provide a discount. And we're also hiring. So if you're excited to come and work on code review, on building call graphs in different languages, on building agents that can help write code, understand code, create PRs. We can go look at the PRs that we just created, actually. Then please also reach out to us. We'd be happy to chat. So we can kind of see some of the answers we had here. Apparently, I spent 24 hours coding today. One thing to point out here is that the coding time is based on like average time it takes an engineer to do an amount of work. That now sounds really bad standing here and saying that, but that at least sort of suggests I was reasonably productive, so that was quite good. But yeah, we essentially look at all of the changes that were involved in all of the commits. And we have an algorithm to basically estimate how long those code changes would take. And so that we kind of estimate coding time as a result of that. And that feeds into a lot of things. It helps you understand, from a manager perspective, like, what's the output of various people on your team. But it also helps you understand from a project level how much time and how much effort is being spent on different things. You can go look at charts like this and immediately see, like, what is our team actually working on? Like the biggest project right now is auth service. And I can go click on that and I can go and see the actual commits that are being done. Like who's working on this? Joe, my co-founder, this is a big project he's working on. Chinru is also helping. Like, has this shipped? Like, well, no, this has pushed it back, but this hasn't shipped yet. But this stuff is shipped, so I can kind of get a sense as to like what's going on, who's working on what, which is really useful. And we also get a sense of like how our coding time is changing over time, which also helps us understand what our productivity is. And you can kind of see like we also are able to look at like what are people's productivity, taking the number of coding hours that we estimate they've spent versus the number of work hours. You can truly prove whether or not you're a 1x or 5x engineer. Apparently, I'm currently a 0.27x engineer, but I'll take it. And we can then generate stats like this. We can see how our code review works. It's able to go do code review and come up with a bunch of insights on like how our custom code review rules work, how our automated AI review works. We did that just by asking a question. And Macroscope's going off and created a branch and generating a PR for me here on this other thing that I asked it to do. So that's really just a high level on Macroscope. As I say, if you have ever been annoyed being pinged by your manager on like what you're working on, if you've ever found it hard to understand what your team's doing but not wanting to go bother people, if you've ever wanted to have a code review tool that doesn't require you reading a whole bunch of comments that seem to mostly be garbage, then we'd encourage you to try it out. You can sign up online. We'll offer a discount. And yeah, if you're excited to come work on any of these problems, give us a reach out and be happy to chat. Cool. Thanks.
You want to do questions?
Yeah, do questions.
Anyone have questions? Okay, you're the closest.
All right. So when it comes to identifying bugs, does it require a robust test suite to be able to figure out where bugs were introduced, or is it just I just tell it the symptoms of what's happening now, and it can go through and identify what changed since then? Great question. So I mean, we're reviewing code the same way that a human reviews code, which is like a pseudo-static analysis, right? You're looking at how is this. We're looking at each code object, each program unit, so each method, function, struct, etc., class. And we're saying, like, how is this used, and what are its dependencies? And we're basically, providing all of that context when we're going through our, LLM pipeline and saying, like, are there any bugs here, right? And we're mostly focused on correctness bugs. We have linters. There's no need to go and pay an expensive cost to go run an LLM for something a linter can do for you. We have compilers. Again, you don't need to go and use an LLM for something where compiler can give you the warnings. What we're specifically focused on is runtime correctness issues, the kind of issues that aren't going to get caught by linters, aren't going to get caught by any of the existing tools, by any GitHub actions, but you're only going to find when you go deploy. And so those are the ones which are really high value, and that's what we spend a lot of our time focused on. But yeah, it's interesting. Like, we're explicitly not focused on a lot of the compilation issues as a result. Thanks.
All right. Yeah, I think I'm the next.
Sorry.
I'll go. So, sorry. My question is, it seems like project management is painful, but it's not hugely painful. But code reviews are really important to do. So in terms of your positioning, are you more focused on the software project management side, or are you focused more on the code review side? What is more actionable for our engineering team?
I mean, it's interesting, right? Because both matter. You can have the highest productivity engineering team, and if you're working on the wrong things, or the team's not working on the things you think they're working on, then what's that productivity in aid of? And so, yes, we want to help engineers spend more time engineering, be more productive with their engineering, spend less time in code review, spend less time in meetings, spend less time having to ping other people about how something works. But we also want to make sure that we know what people are working on, so people are working on the right things. We avoid those situations where a team's gone off for 2 weeks and worked on something because of lack of communication that actually was completely the wrong thing or contradictory to what another team was doing. And so we really see these two things as being synergistic, and we really think you need both in order to have a highly productive engineering organization. I mean, making sure your code doesn't have bugs in it is pretty important. So, making sure we do that well is pretty critical. But, there's also a lot of bug-free code that's shipped that doesn't matter.
All right, we have one more question here.
So I was a programmer a long time ago, and I saw how you quantify the amount of hours that someone spent in coding, and I don't know how you quantify the quality of code, the impact of the code,
Yeah.
the level of seriousness of the bug.
Yeah.
Is there any way to quantify all of that? And is there any way to hack it as a programmer? To say, okay, I actually worked 23 hours a day, but actually only worked 3 hours.
Yeah.
Thank you.
We have a great bug. I can't remember if we fixed yet, but we didn't really handle reverts properly. So every time you reverted code, you got the same amount of credit as you did when you wrote it in the first place. So someone discovered that you could just ship and revert endlessly and have a really high 5x engineering score. So there's definitely ways to hack it. It's always the fun of being an engineer is finding a way around these systems, right? But no, I mean, at the moment, we're mostly trying to understand how much time is being spent on things to help give a sense of what's being worked on. Most organizations have a sense of their priorities, but does your priorities actually align with the things people are spending their time doing? And it is also useful from an engineering management perspective to know how busy are these folks. But really, the real value is understanding what's being done. It seems like people are busy with this thing, but is that actually what they're spending their time on? Or are they spending all their time fixing bugs in another area? And that was, again, when we were at Twitter, that was the biggest problem, right? Understanding what was actually being worked on versus what we wanted people to be working on, and where the time was going was a huge problem. And so the idea is that you can now just solve that automatically without meetings, without project managers, without people being pinged, and just let engineers continue building stuff. Awesome. Great. Well, thanks so much. It was really great to chat. Thanks, everyone.